Hey, good afternoon, everybody. Thank you for coming out. My name is Prabhu Barathi. I'm part of VMware's enterprise cloud strategy team in the Northeast in the United States. So, thank you for taking the time to come to my session. The session here is what is service mesh and why do I need one? So let's get started. There is a disclaimer here, just so that everyone is aware. In full disclosure, some of the stuff we are going to be talking about is currently in development. The look and feel and some of the features that we may talk about will and probably look a little bit different by the time the product is delivered. So just wanted to throw this out there for folks, and especially given it is being recorded. So if you do watch this years and years from now, don't be surprised that it looks very different from what is on this video. So just by ways of agenda, like what we want to cover is why service mesh. If you're like me and you're on Twitter, you're probably wondering like why is everyone up in arms about the need for service mesh or the lack of need for service mesh, right? So we'll talk about like why is this actually important. So just to give you a little context of how did we kind of land in this space. We'll talk a little bit about service mesh in general. This is not necessarily specific to like what VMware is doing in this space, but this is more generalistic view of what is service mesh and why is it actually important for you to consider. We'll talk a little bit about what the functionalities are and what the service mesh actually enable for you as an end user. And then, what are we doing in this space? A lot of people don't associate VMware in this space, so what is VMware really doing as it pertains to service mesh, right? So why service mesh? And I always like to use this as, like most of us, if you go into Twitter, you'll always fall into two camps of either I need something really, really badly or I don't need it at all. So depending on what you find on Twitter, it can be, hey, you need service mesh and you need it like yesterday. So why is it that is the case? So if you don't run this today, chances are very high that either you're going to be running a microservices-based application or someone at your company is already running microservices-based applications, right? And the goal there was to basically be able to deconstruct a monolithic application and run this as efficiently as possible into smaller pieces of code so that you can do things like upgrades and a lot of other things that brings together the promise of microservices in general. However, when you actually take a step back and actually talk to a lot of people who are running microservices for any duration of time, most of them will tell you that there's a lot of promise that microservices brings to the application owners and the business owners, but there are a lot of challenges that customers have to overcome. Now, don't get me wrong, I'm not saying microservices is not the answer to things. The pros of what a microservices-based architecture brings far outweighs the cons in that sense, but there are a lot of things that you need to be able to be cognizant of as you look towards leveraging a microservices-based environment. So, few things that really come to bear are the interactions that you want to consider between app owners and service owners. You may think about it and go like, are they one and the same? They may not be actually the same. So service owners, and you'll see as we go through the presentation here, service owners may or may not be the application owners or the app developers in a lot of sense, right? So they could be folks who own a very specific part of the application that they are responsible for and the maintenance of that component that they are actually looking for. And how does a service owner actually interact with the app developer, and how do they provide a level of service to the application itself? Now, on the other side of the spectrum are DevOps, SREs, platform engineers, and so on. How are they actually interacting with something like this, and how do they provide the R in what the R in the SREs and the PREs provide, right? The reliability of the platform and of the application. How do they provide this to the end user? Again, now taking this further, how does security operations and compliance actually fit into this? So there's a lot of other things that now start to layer on as you start to build up a microservices-based application, right? So one thing which is kind of a misnomer, and I find this pretty often, is the notion of microservices equals containers. So microservices doesn't necessarily mean that it has to be leveraging a container-based platform, right? You can absolutely build a microservices-based architecture on VM-based stuff as well. There's nothing that stops you from using it. The only thing is that the containers provide you a much more lightweight footprint in order for you to consume a microservices-based implementation, right? But like I said before, the idea behind deconstructing a monolith is really around being able to separate the functionality into smaller parts that can be created independently, they can be managed independently, but when it comes together is really when the application really comes together as a whole. Now, the beauty of the system is the fact that now you can start to build stuff based on multiple languages, right? So for example, if you're doing caching, Python could be super useful for caching. For a web front end, Node.js could be your platform that you're picking up, right? Now, how do all these things communicate together? And that's where APIs really play a big part, is that you want to be able to leverage a language agnostic API model to actually be able to provide a way for these different tiers to sort of communicate with each other. So now that we've actually looked at this, we take this one step further into how do I operationalize something like this? There are a bunch of challenges that you start to kind of see at this point. So number one is around app silos, right? When you look at the different languages that are being utilized, so you could be leveraging Java, you could be leveraging Node.js or Ruby or whatever, there's now silos of how you're actually communicating. There's different libraries in all of these things that they need to communicate. Yes, at a much more higher level, you've aggregated that as an API layer, but even then, the applications, if you think about it, are actually kind of running in a silo on multiple different platforms and multiple different languages. In a lot of cases, they could also be leveraging multiple cloud-based environments, right? So they could be running on-premises versus public cloud. So there's a lot of other things that start to make their appearance now. As the endpoints start to ramp up, you're also starting to say, hey, the number of endpoints that I'm monitoring is also starting to get really, really high. Now, in terms of operational visibility and the ability to remediate, now we're also running into a situation where the tooling that I have in place is kind of inconsistent in how I'm actually delivering this. And lastly, the best practice, if you think about it, is to leverage the best libraries and frameworks that is suited for the application and the microservice that I'm trying to build. That is the way we want to build this forward and build it in a polyglot kind of framework, right? So we want to be able to do that. But how do we kind of bridge this gap and how do we bring all of this stuff together? So this is where one of the approaches that a lot of customers are starting to look at is the ability to look at something called service mesh. So service mesh at a high level is, and this is not just VMware's definition, this is as a whole, what service mesh is really doing is service mesh is providing you an abstraction layer that is able to take care of things like service-to-service communication, so meaning I have service A, service B, service C. How does the service-to-service communication actually happens? If I need to encrypt the communication between the services, if I need to enable mutual TLS, as an example, that's a way for me to do it. And start to provide observability tools, meaning can I provide monitoring, can I provide tracing? If I need to do circuit breakers, as an example, if I need to do retries. So how do I enable all of this in a way that is abstracted away from the code that I'm actually basically creating? That is really what service mesh actually is aiming to solve for. And key there is that abstraction layer, right? So let's look at how is this actually any different from how we run stuff today. So if I take a web service as an example, this is an application that is, say, broken down into different components now, right? So if I take my web service as an example, this is written in C# right now. And I have a REST API, I have all that fun stuff created. What is the web service actually supposed to be doing? It is supposed to be fetching data and presenting it on a web page. That's all it's supposed to be doing, right? But where is it actually fetching the data from? The data is coming from different services. So it's coming from service B, C, so on and so forth. Now, service B could be written in Ruby, it could be written in Java, whatever, right? Now, all of these things now we need to be able to come up with a way that I need to be able to define how does the web service actually go and pull data from my service B and service C and so on and so forth. And all I need to go and define is saying, hey, how do I find these services? Connection details, meaning do I use secure communication patterns or not? And these are different languages, end of the day, right? So how do I now kind of build all these things together? There are other things that actually now start to make a difference. Now, things like latency detection. Now, applications are very latency sensitive. So now if there is actually a latency that has been injected into the application for whatever reason, I need to be able to find what is that latency how is this latency being injected, and where is this latency actually happening? And I need to get metrics on it. I need to send these metrics somewhere so that I'm able to at least alert on it and provide some way of self-healing, right? So if I need to do retries, if I need to stop retries, I need to be able to define all of this in some shape or form. In a monolith, you would just package all of this stuff together. Now, in our case, what we're going to actually do is actually put all of this into something called a layer 7 proxy. The proxy is really that abstraction layer that we've been talking about. If you think about it just from an OSI model kind of approach, this is your data plane that we're talking about. I can take all of the stuff we just described about and put this into an abstraction layer or a data plane component that is called a layer 7 proxy. And that's the big difference here, right? The web service does not contain any of the information that we talked about. The proxy is really the one that is actually taking care of all the details that we need to define for service-to-service kind of communication. So if you're familiar with Kubernetes, your pod is your smallest abstraction that you can kind of go with, right? So before, what we would do is package all of the stuff we talked about from a mutual TLS connection mechanism, metrics, retries. We would define all of that as part of the container itself. Now, instead of doing that, one of the methods that is actually becoming very, very popular is the ability to use something called a sidecar. Sidecar is exactly what you're imagining. The first time I heard a sidecar, I imagined I was on a scooter and there was a sidecar next to me. And that is literally what it is, right? There is another piece of software that is actually running inside the pod that is doing all of these non-differentiated functions like what we described. Meaning, can I define TLS, metrics, retries, all of that is defined as part of that sidecar. So the heart of the service mesh is really something called Envoy. So Envoy is an open source project that is out there. The project was started by Lyft, and it's now fully owned by the CNCF Foundation. What it is actually doing is really providing you the ability to kind of define all the things we talked about, right? In terms of what the connection protocol needs to be, does it need to be HTTPS, can I talk on gRPC, with or without MTLS, and so on and so forth, right? So that's the stuff that you're actually defining inside of that layer 7 proxy and Envoy. So having said that, like, what is it that I'm able to now get out of all of this? So the question that a lot of people ask is like, that seems a lot of work, but what am I actually getting? What's the benefit for me as an end user to actually do all of this work? So let's look at a couple examples of some implementation that we can start to do with this. So one of the things we can start to do is some things like traffic splitting, right? So one of the benefits of leveraging microservices kind of architecture is start to do things like canary deployments, meaning I can deploy two services that are identical, but one of them is, say, like if you want to do A/B testing as an example. Now, if I want to do something like that, I can use things from inside Kubernetes and say, 99% of the traffic needs to go to the pod label that has got version 1.5, and 1% is going to go to pod label version 2.0. And then I can keep switching that over, and then I can do this kind of traffic splitting. And all of this is done leveraging the YAML templates that you're already leveraging from that standpoint, right? So you're no longer doing these kind of things, leveraging, say, a higher level thing like a load balancer or something, right? So you can do this in a much more easy, routine fashion, and you can start doing things like traffic splitting is one of the best use cases that you can try out. Another thing is starting to do traffic steering. So traffic steering is based on the concept of leveraging content-based traffic steering, meaning if I'm using, say, a user agent is coming on Android versus iPhone, I can send them off to different services. I can send them off to service B and different services. I can do things like that, where I'm leveraging content-based headers and things like that to start to steer traffic to different services. Now, another thing what we can start to do is start to centralize my visibility metrics, right? So there's a component inside of Istio which is called Mixer. So Mixer basically is what it's going to do is it's going to collect all the metrics that are being generated by the containers, and I can start to bring all of that together, normalize them, and then start to send it off to an external platform. So if I'm leveraging, say, Prometheus, InfluxDB, Wavefront, any of these platforms, I can start to aggregate that and then start to send that off into my third-party system that I want to do it. The beauty of this is that because I'm aggregating everything inside of Mixer, the backend metrics can be swapped out anytime. So meaning, if I'm leveraging Prometheus today, which is an open source tool, I can tomorrow say, hey, you know what, my Prometheus system is it's not really working out for me. I can swap that out with another system, and that works great for me as well, because I've actually aggregated everything at that point from a metrics perspective. Same thing from a tracing perspective, The application actually now doesn't need to start to provide me the metrics and say, hey, this is how I'm communicating between my web and app and database. I can run those traces and figure out how are my API traces actually working, because I'm doing a similar kind of aggregation at the mixer level, and I can do the same thing here. I can swap out the backends if I'm leveraging Zipkin versus Stackdriver, or I build a custom backend. I can swap out all of those things in the same manner at this point. One of the other things now we can do is things like retries, right? I can start to write vendor agnostic and language agnostic failure detection, and the ability to start creating retries, meaning I can set up and say, you should do per try timeout is going to be 2 seconds or 3 seconds. How many times should I continue to retry before I call this a dead connection, right? And then report that as a dead connection. How many times am I going to do that? I can do this in a much more lightweight, vendor agnostic, language agnostic kind of way outside of this, and put it into the layer 7 proxy is what I can kind of do here. So having said all that, the question a lot of customers ask is, oh, that's all good. This is an open source project, so what are you guys doing? Like, why is VMware in this space? What is VMware's contribution to this? So if you actually go back in history, so I'm assuming a lot of you are kind of familiar with our networking and security portfolio. We started this journey kind of a couple of years ago on how do we basically provide a network virtualization layer for the data center. So from that point, we've basically taken that. The next evolution of that was how do we provide networking and security to our application platform, meaning how do we provide the same networking and security parameters to things like Kubernetes, as an example. And the next evolution of that is the ability to bring all of this together in form of a service mesh. And that's what we're able to now bring to you as our end users. So what we're trying to build out is really an enterprise class service mesh vision is what we're trying to build out, whereby we're able to actually connect all of these different components that we talked about from a discovery, visibility, control, and security perspective, and having the knowledge of users, services, and data, we're now able to actually bridge all of these worlds together and provide an end-to-end enterprise class service mesh for our customers to actually consume and build out, right? So the key use cases that we're targeting with our implementation is very similar to what the core open source project is actually delivering. In that sense, is the ability to do discovery, basically be able to discover and analyze the relationships and the dependencies it has with the users, services, and data. Provide the visibility, because that's a very important piece here, to provide the end-to-end topology, provide the monitoring and tracing. Be able to also provide resiliency. The R in, I always go back to this, is the fact that the R in SREs and PREs is the reliability. How do I basically create SLI and SLO policies that will map to the reliability of the application? Now, how can I also start to secure this? Now, how can I basically say if there are 2 tiers, they need to be communicating on MTLS at all times? That's a way for me to start to lock down these microservices at that point. And the last piece is also, how can I start to federate, right? There's no federated approach that is out there today, which basically, if you are running Kubernetes inside of, say, as of PKS, as of in Azure, in Google, whatever you may end up running, these are independent stacks as they stand today. Our vision of providing this is to really provide a more federated approach of what the service mesh is eventually kind of going to look like. And that is actually really the differentiation here. So if you look at some of the vendors that are out there in the space, is basically being able to provide, say, isolated components in that sense. Now, with NSX SM or NSX Service Mesh, we're basically providing you a much more federated approach, whereby we can run workloads in, say, on-premises PKS, and then also run in stuff in GKE, and we can provide a much more federated approach in terms of how we are actually delivering the mesh itself. Now, a lot of the stuff you will, if you want to be able to look at this in much more detail, there's two deep dive sessions tomorrow. I believe it's at 4 o'clock in the afternoon tomorrow. So if you want to see this in action, we have one of our principal engineers who will demonstrate this live in person, so you can actually get a feel for what the use cases are and how this is going to work. But ultimately, the question that I started with is this really for you? What do you need to do, and what do you need to learn from this? Is really, you know, the more I talk to customers who basically tell me is start with one use case and incrementally adopt the others as you gain more familiarity with the platform. There's a lot of things to chew off if you think about it from just a service mesh perspective. It's always good to start out with just one use case, one application, one microservice, whatever that is, right? Start out with the smallest unit that you can, and then incrementally you can start to build yourself as you go forward. So with that, I'd like to wrap up by saying, hopefully this was useful, and the product is available in early beta right now. So if you are interested, again, like I said, please attend one of the deep dive sessions. We have only had 30 minutes here, so we kind of ran through a bunch of different topics, but definitely take the time to attend one of the deep dive sessions. I think it's one of the most exciting topics that is out here. So again, thank you again. Thanks for your time, and appreciate it. Hope you have a wonderful time in Barcelona. Thank you.